Hello everyone, my name's Mrs Jennison and I'm an Associate Director for Outgrange Academies Trust. Today's lesson is on soluble salts. Our challenge for today is to be able to describe how to make soluble salts. Our aspire is to be able to construct word, balance symbol equations and ionic equations for reactions to make salts. And that is higher tier content. Before we get started, we just have a quick recap from our previous lessons. On the screen is a chemical reaction. What are the reactants in this reaction and what are the products? What is magnesium chloride known as? And if you can you please balance the equation? So the reactants were magnesium and hydrochloric acid, and the products were magnesium chloride and hydrogen. Magnesium chloride is known as a salt, and to balance the equation you would place a 2 in front of the hydrochloric acid, as there are 2 atoms of hydrogen in hydrogen gas, so you require 2 molecules of hydrochloric acid. Now in today's lesson we're going to be using some key terms. The first one being soluble. Soluble means that a substance is capable of being dissolved, easily dissolved in some solvent, and the solvent we use is typically water. Insoluble means that a substance is incapable of dissolving into a solvent. A salt is an ionic compound that contains a metal ion and a non-metal ion. Now salts, as we've just said, contain positive metal ions which come from a base or an alkali, and a negative non-metal ion that comes from an acid. So for example, sodium chloride, table salt, potassium bromide, and magnesium chloride. Now salts containing group 1 and group 2 metal ions tend to be white crystallized solids. However, in the cases of cobalt chloride, iron sulfate and copper sulfate, these salts contain transition metals from the middle section of the periodic table, and they are coloured crystalline solids. Now naming salts is linked to the acid which we used. Hydrochloric acid forms chlorides, sulfuric acid forms sulfates, and nitric acid forms nitrates. From our previous lesson, we learned that acids are neutralised by alkalis and bases to produce salts and water. They can also be neutralised by metal carbonates to produce salt, water, and carbon dioxide. Now, we have already looked at the reaction of acids and metals, and in acids of metal hydroxides. So in this lesson we are going to look at the reaction of acids and metal oxides, and then acids and metal carbonates. So first of all, we're going to look at metal oxides and acid. Now acid reacts with metal oxides to form salt and water. Metal oxides are solids and insoluble. Their colour depends on the metal that they contain. So for example, the powder we can see on the screen at the moment is copper oxide, but they can vary in colour. Metal oxides can also be described as bases. Now, bases react with acids. An alkali is a soluble base. Just like alkalis, metal oxides also undergo neutralization reactions when mixed with acids. So an example of this would be the reaction of hydrochloric acid with copper oxide. Now, the copper reacts with the chloride ion and forms copper chloride. And the hydrogen ion from the acid reacts with the oxide and forms water. You can see this quite easily on the symbol equation. What I'd like you to do now is I'd like you to complete word and symbol equations for each of the examples below. So, copper oxide plus sulfuric acid would make copper sulfate and water. I've placed the symbol equation on the screen for you to check if you attempted it. Sodium oxide and hydrochloric acid would make sodium chloride and water, and again the equation is on the screen. Iron 2 oxide and nitric acid would make iron 2 nitrate and water. The reason we have the 2 in there is because iron is a transition metal, so it can form ions of different charges. I've also placed the symbol equation on the screen for you to check yours with. Now we're going to look at the reaction of metal carbonates with acid. Now, the general equation for these reactions is acid plus metal carbonate will form salt and water, but this time they also produce carbon dioxide when they react, which means we will see some fizzing. Now, there's many examples of carbonates, sodium carbonate, calcium carbonate and potassium carbonate being some of them. The reaction looks very similar to that of acids with metals, as we are getting that gas produced. So the only way we can tell the difference is by testing the gas produced. Now, in the acids with metals video, we tested the gas to see that it was hydrogen. So in this one, we'll have to test the gas to prove that it is carbon dioxide. We have recorded this, so I'm going to insert a video of this reaction and of testing the gas here. So this is a demonstration to show you the reaction between a carbonate and acid. So in this test tube here are some pieces of calcium carbonate. And what I'm going to do is I'm going to add some acid to that carbonate, and this is hydrochloric acid. Now you can see that the reaction starts to fizz, but the gas produced is colourless. So I'm going to perform a test to test for that gas. So I'm bubbling that gas via a delivery tube, I'll just show you the setup there, into a second test tube containing some lime water. And at the start, this was colourless, but you can see as we bubble the carbon dioxide through it, and we now know that it is carbon dioxide, the lime water turns cloudy. And this is a test for carbon dioxide, which means we now know that the reaction of this carbonate with acid produces carbon dioxide alongside the salt and the water. Now that we've done that, I'd like you to have a go at completing word and symbol equations if you can for each of the examples below. So sodium carbonate and hydrochloric acid would produce sodium chloride, water and carbon dioxide. And you can see the symbol equation on the screen. Magnesium carbonate and nitric acid would form magnesium nitrate, water and carbon dioxide. And again the equations on the screen, remember those brackets around that nitrate ion. And copper carbonate with sulfuric acid would form copper sulfate, water and carbon dioxide. And the equations on the screen. So let's have a look at an exam style question on this. Copper sulfate can be made by the following general reaction. What type of a reaction is that? The base used is copper oxide. They want you to give the name and chemical formula of the acid used. And then a student wrote about how copper sulfate was made. And they said that some of the acid was warmed, copper oxide was added, the mixture was stirred, more copper oxide was added until no more would react. The mixture was then filtered. They want you to say why the acid was warmed And copper oxide was added until no more would react. Why do you think this occurred? So the reaction was neutralization. The acid that would be used is sulfuric acid. You get 1 mark for that, and the second mark is for the formula H2SO4. The acid was heated up to speed up the reaction. And the reason that they continued to add copper oxide until no more dissolved is so that all of the acid reacts and that the acid is neutralized. Ionic equations. In reactions that involve ions, the ionic compound can split into its positive and negative ions as the chemical is dissolved. We represent a solution which is dissolved in water with the state symbol brackets AQ and can write the ions as seen on the screen. So HCl, when dissolved in water, forms H plus ions and chloride ions. Now below is the reaction of nitric acid with sodium hydroxide. You can see nitric acid plus sodium hydroxide forms sodium nitrate and water. But what we can do is we can also write the symbol equation HNO3 plus NaOH forms NaNO3 plus H2O. You might notice that the HNO3, NaOH and NaNO3 are all aqueous, which means they are dissolved in water. So actually, those compounds split into their ions in that water. This means that that symbol equation could be split into its ions and it would look like this. The H plus, which is the acid, the nitrate ion, the sodium ion and the hydroxide ion. And on the product side, we still have the sodium ion and the nitrate ion, but the H plus and the OH minus have reacted to form water. Water does not get split up because the water itself is a liquid. Now, You can see that on both sides of the arrow there are some ions that are the same. So these are actually called spectator ions because they're in the reaction but they're not taking part, a little bit like spectators at a football match. And we can cancel out those ions from our equation because you can see the nitrate ion is on both sides and the sodium ion is on both sides. And that leaves us with the general ionic equation for a neutralization reaction. H plus from the acid reacts with OH minus from the alkali and forms water. Now that specific equation is called the ionic equation for neutralization. It's called that because no matter what acid we are using or alkali we are using, once you cancel out the spectator ions on both sides of the arrow, we are left with this equation. And a top exam tip will be to make sure that you learn that equation and you know where the ions are coming from. So now it's time for you to have a go at an exam question on this. We'd like you to explain in terms of ions and molecules what happens when any acid reacts with any alkali. So you should have that the hydrogen ions from the acid, H+, and hydroxide ions from the alkali, OH-, react to produce water. But in this case, the ionic neutralization equation would have gained all 3 marks. So just before we leave, I'm going to play you a song that uses this ionic equation, and I hope you enjoy it.
Because you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, bass. Yeah, it's pretty clear, I ain't no science fool. So you got litmus, well I can turn it blue. Make it go boom, boom all over the place. When all the H plus meet all the OHs. Pink phenolphthalein, I think that's straight dope. Mix in a lipid here and it'll make it soap. You want it neutral, pH is low, better set up a titration with a strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. If an acid gets in them, we just have to neutralize. You'll know I love me, my stomach, and all the things it dissolves. But my bile duct keeps it from eating my intestine walls. Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Ha! I'm gonna do the math to figure out the ratios to react. Stoichiometry, yeah, that's where it's at. And it'll tell you
to prepare at least 1 molar for your strong hydroxyl drop.
Yeah, my lab tech, she told me don't worry about your eyes. Cause if acid gets in, we can fix it with alkalis. That always know I love me, my stomach, and all the things it dissolves. But my bile duct keeps it from eating my intestine walls. Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Ha.
And that's everything from me, and I will see you soon.